In case you want to put a question, you can unmute yourself at any point of time. All right, so here we go. Well, so my name is Anshu Pandey. I work as a senior technical consultant for Tech Ventures. I am primarily a data scientist. So from last 8 years, I have been working as a data scientist and data science associate and similar other roles. What I do now is I help enterprises to design their data science strategy and the architecture of the data science transformation and the AI transformation that they are planning out. So that's what I do, and that's a super interesting job. So now let's get started with the main topic of this particular workshop, which is we're going to talk about what exactly is data scientist. Sorry, what exactly is data science in general? So primarily, maybe many of you would have taken some courses, or maybe you would have, as you're having some interest in data science, you would have already gone through few examples, possibly videos, possibly some introductory sessions as well. So you may or may not be having a little understanding of the topic, what exactly is data science. So let's have a quick look at that. So when it comes to understanding data science specifically, it's a field of technology where we make use of structured data, where we make mostly use of structured data. We apply statistics and visualization on the top of structured data to perform analytics. Plus, it's a field which also leverages the power of deep learning, machine learning, and AI. So primarily, artificial intelligence is a field which deals with developing intelligent solutions. And so there are a lot of algorithms in AI which can be used to develop intelligent solutions. Few of those algorithms which use data to build intelligence are part of a subset called machine learning. So there are many algorithms in machine learning, right? And all of the algorithms from AI which use data are part of ML. There's another subset of ML, which what we call as deep learning, and that's where we have a set of algorithms which perform automated feature engineering. That means they select the features automatically in order to build a predictive model. So these are the three categories of algorithms which are used to develop predictive models. Data science is a field which leverages these fields like machine learning, deep learning, and AI on the top of data, primarily structured data. And data science is not only concerned with ML or deep learning and AI, it also is, it also includes a very important field, a super important field, I would say, which is data analytics. And that is where what we do is we sort of apply statistics, visualization on structured data, right? So there are two forms of data in general, structured and unstructured. Structured data is like anything which is tabular data, like Excel sheet, CSV files, SQL database tables are examples of structured data. Unstructured data, which is like images, videos, text, audio, these are all examples of unstructured data, right? So data science mostly, in data science, we mostly deal with the type of data which is structured data. Right. And so yeah, that's one of the important things, right? So I hope this makes a little sense about what exactly is data science in general, right? And so primarily it includes two different fields. In fact, we can say three different fields, which starts with data engineering, where we start collecting data. Second is analytics. Third is where we apply ML or DL. Right, so that's about it. That's a generic overview idea. This workshop mainly not focuses on giving you the fundamental understanding. Like we could have spent around 1 hour on this single slide to understand and talk more about each and every terminology. This workshop is going to focus more on bringing you to a practical aspect of what kind of problems do we usually solve with data science, and how do we assess those problems, and how do we approach any standard analytics problem, you can say, in general. Right. So that's a focus of this workshop, and that's where I have very few slides which we are having discussion on currently, and those are also incorporated in the student notebook. So we are not going to go through any PPT after this, right? So yeah, that's where we're having a little limited discussion on these terminologies, right? And so that's what the idea about data science in general. Moving further, the question is like, which programming languages do we use in data science in general? The answer to that is there are two popular programming languages, which include Python programming and R programming. These are the two most popular programming languages you can say that are available today so far, and for Python and data science, right? You have Java and a lot of other programming languages for different other tasks, but yeah, these are the programming languages mainly used for data science specifically. So R is very popular for statistics and analytics, but it's more of academic language. That means it is very much limited to universities and research fields. Python is more industry-oriented language. R is less deployment friendly. That means if you have to develop a solution at the end of the day from the data science part, Python becomes more friendly to deployment and developing a solution. R becomes a little less friendly with that. When it comes to deep learning or specifically computer vision or natural language processing, Python becomes super powerful in that case compared to R. So that's a very idea about it. Next, let's go further. So we're going to be using Python in this particular two-day workshop. So I hope it is expected that you have a little idea of Python, fair idea of it. So we're not going to be learning Python in general in this course. We're just going to be using Python for analytics. That's one thing. Now, this is a super important topic of the whole workshop, I want to say, which is understanding the whole idea of more of enterprise level idea of how an enterprise consumes technology, specifically the technologies related to analytics and data. So when you look at the, when we closely look at the journey of any enterprise with data, right? So how do they start and where do they end with data, right? So what are the stuff that they do with data, and what are the things that they explore and kind of applications that they develop, right? For any enterprise, you talk about banking, you talk about finance enterprise, or you talk about manufacturing entity, or you talk about supply chain management, healthcare, education, oil and gas, mining, any company you talk about, how their journey goes in when it comes to consuming data. So the very first question that they ask is, what is happening in the business, or what has happened in the business, right? So let us say that I am having a business. So let's say, if I'm owner of a few Domino's shops or outlets, I would want to know that which of the Domino's outlet is making more sales or how much sales it is making. I want to know that how many, whether people are coming or buying products in evening or morning or afternoon slot. When they're coming in morning, are they buying big dishes? That means are they coming with family or they are coming standalone? When they are buying pizza from Domino, are they ordering via online channels like Swiggy, Zomato, or they are ordering via offline channel, walk in the store? So I want to have very fair and clear idea of how my customers are engaging, how many sales I'm making across multiple outlets of Domino, right? And how my business is performing. So the main aspect is I would want to know as a manager or as an owner of business, what is happening in the business, or what has happened, how many sales I have made in last 6 months, how much profit I have made in last 2 years, and how my employees are performing. These are very fixed questions which business would want to get answered to every now and then. This is the very first step, which is where they want to start consuming data, because data is only thing which can answer this question. As an e-commerce company, if I'm having an e-commerce business, I would want to know that how much sales I'm making in different part of the country, how many products or which category of products are being returned more, how much profit I have gained from electronics, apparels, let's say groceries, XYZ like that. Where my products are being consumed more, tier 1, tier 2, tier 3 cities. Are my users buying more from smartphone or they are buying more for web applications, right? Where do I need to do optimization in general? Which products are usually sold more in month of August in last 5 years Based on that, I would want to possibly put a marketing discount on that product, or maybe some other product possibly. So I would want to know what has happened in the past as well. And this is where a business starts consuming data. This is where a business starts exploring opportunities to get the solution to this. And that's where what they want to do is they want to get a description of the data. So the business already captures each and every data point. So whenever we buy anything from e-commerce, they capture data of the product name, the time of the purchase, and the amount of the purchase, the delivery address, the location, everything. So they want to know a descriptive idea of how the sales are being done. And the answer to this question, so it's a little misaligned. Let me just. The answer to this question, the business gets from a field called as data reporting or business intelligence, BI in general, or data reporting. So as a, this is one of the other, if you are a fresher or you are a college student possibly, or maybe you are switching to data science or data analytics, this is one of the entry-level job that you can get in the business. You can get as a BI professional, or a business intelligence expert, or possibly a BI manager if you're already working in the field of BI. And this level doesn't require any programming skill. There are very popular tools like Tableau BI, Power BI, ClickSense, ClickView. These are very super popular tools widely used in the market, which are more drag and drop interfaces, and these are used to develop dashboards. So if I show an example of what you accomplish out of this is, you might end up developing a Power BI dashboard for an enterprise, which they can use for analyzing. Let's see if I show you sales dashboard, right? So this is how a sales dashboard looks like. So you see this dashboard simply shows me, maybe this dashboard simply shows me right. So let's say this particular dashboard simply shows me the sales for a particular organization, right? So if you look at that, it's being loaded here. So this is for Cloud9 Infosystems, and let's see the dashboard here. So this kind of dashboard you accomplish creating with help of Power BI or Tableau BI, right? So this dashboard simply helps me the, I want to see the Asia Pacific report. So it is going to simply filter out all the graphs to Asia Pacific. So these are the sales I'm making in Asia. Estimated revenue I'm making in Asia Pacific, February, April, June, July, August, September, October, right? And this is possibly opportunity value by pipeline. And so I can look at the country, let's say India. Specifically, these are the possible estimation in the month of July, August, September. How is the sales going to happen in future, right? Actual versus target revenue, right? So actual revenue versus target revenue. These are different charts it shows, right? If I go next further, I can see different charts, sales performance. Let's say I want to see for India specifically. So this is the sales performance of for Japan. So this is what it enables. So this enables the enterprise leader or the decision maker to understand that what is happening in the business, right? Or what has happened in the business. So far, how has been my performance in past few years or maybe few months, how my company is performing, how different outlets are performing, how well they are doing, how much revenue am I generating, how much profit am I making, what are the trends available, right? And where my business is heading to, where am I making losses, right? So this is what the business gets answered to from the very first step where they enter into the world of data, or the very first step they take when they start their journey with the help of data. And this has to be a first step, the first step for any enterprise. Some of the enterprises overlook this and maybe they kind of try to sort of shift on the top of this, but and later they have to come back. Most of them have to. Now over here, this is the very first step business should go in. This is a step where after implementation of such dashboards, the business identifies the opportunities of what data to collect or what data is important, the data quality issues that they have been doing, right? So a lot of businesses are just keep on capturing data and they don't use that data. This is the step that they start using it and they identify the issues with the quality of data that they're capturing, and what other data points that they are missing, or they would want to capture that, right? And from here they get different questions, right? So this dashboards, the very first step, help the business to ask question. So let's say, if as a manager, if I see that my profit has been going down from last 6 months, I would want to know that why my profit is going down. If my customers are not coming back to the portal, let's say I'm owner of a xyz.com e-commerce chain website, so only customers come for the first time, they are not returning back to my platform. So I would want to know that why my customers are not returning back, why they are churning. If my sales are going down, I would want to know that why this happened, why my sales are going down, why it happened in the past. So the second question the business asks is why it happened in the past. What so happened that this problem has occurred? The problems keep on changing. The problems do not stay static. Let's say in 2020 I might have issue with why my sales went down. In next year I might have issue as that why my customers are returning the products, or why are not they buying apparels, why are not they buying groceries, but they are buying electronics on my website, right? But why are not they spending much in groceries, right? So why it happened in past. This field is what we solve with something called exploratory analytics, and we also call it as data analytics. So when you look at specifically data analytics in general, data analytics, which specifically relates to the field of answering the question why it happened in past, why customers left the bank, why people are not buying Airtel SIM cards, why possibly machines are not manufacturing good quality products, right? Why machines are getting damaged, why sales are going down, why profit margin is decreasing, why customers are returning the product, right? Why the supply chain management or delivery is being delayed, right? Why are we getting a lot of complaints from customers? Why we are not able to sell in the central part of India, but we are able to sell in western part of India? All these questions of why it happened in past, those questions are answered in data analytics. These first two questions relates with mostly past data, and that's why we use statistics and visualization to help answering these questions. This third stage where the business has to switch sequentially, and after this stage they reach to this stage. So let's say if I identify that I'm making low sales, so I would want to know in future, in next 2 months, how much sales will I be able to make. Based on that, I would want to revive my policy of my business and improve the business. So the next question the business would want to have is what will happen tomorrow. This is what we call as predictive analytics, right? And this is where we consume machine learning, part of AI, right? This is where data science starts using machine learning. Mostly the part of machine learning we use is supervised machine learning. The tools that we use is Python R. Well, in this case, we use Python R and big data as well. Here we use mostly Python and R programming. We build models which can be used to do predictions. This is the third stage. A lot of business would want to, or they try to switch directly to the third stage, which is where they make mistakes because if they have not picked up the right journey, they get into the situation of not having qualitative data or not solving the right problem. The fourth stage where a business would want to consume, and very less of the businesses are on this stage at the moment. Only the big giants like Facebook, Amazon, Google are on this level. How can we make it happen? They use recommendation engines and stuff like that to predict, or maybe to use ML to make customers buy product, right? So how can we make it happen? How can we make the sales go high? Prescriptions, like the way doctor gives prescriptions, that this is the medicine you should take to get well soon, right? Similarly, a machine learning algorithm can give prescription that this is the advertisement you should pick up, or possibly these are the steps you should do, or these are the customers you should sell so as to get more sales out of it. So we call it as prescriptive analytics, right? That's the main name, and we consume here unsupervised machine learning algorithms, and the technologies used are Python, R, and big data tools. Right, so that's about it. That's about the journey of an enterprise with data, and specifically we call it as more of you can say specifically call it as data science journey as well, right? So you can also call it like more of a data science journey. Right. So I hope this makes sense, everyone. Any question that you have till here? Because now we're going to shift to the practical part, and that's where we're going to be actually working with one of the use case on this level to answer this question, why it happened in past. Any question? Are we all good so far? right? So considering that we all are good, we'll go ahead. We'll move forward, right? So we'll take a step forward. Okay. So let's go further, and now we're gonna be working with a project which is actually from this particular part. You can call it as so. These all four are part of data science engineering, right? And we're gonna be starting with the second stage, which is like why it happened in the past, right? Why something happened. We call it as exploratory analytics, or in general data analysis. We also call it EDA, exploratory data analytics. Sometimes we call it root cause analytics, RCA as well. The tool that we'll be using here is Python, right? So that's the tool that I'm going to be using up. So our project is to work with and answer the question in a factory. So we have data of a factory, right? A manufacturing factory. And we are expected to answer the question why machines are damaged in the factory. So we have the data of a factory, and there are machines in a factory. So we have data of around 1,000 machines of a factory. The data collected includes specific properties of the machine, like the lifetime of the machine, so how many months it's been the machine is in use, when the data was recorded, what was the condition of machine, whether it was damaged or it was not damaged, the pressure on which the machine was operating, the moisture on which machine was operating, the temperature on which machine was operating, the team which was handling the machine, was it team A, team B, or team C, the provider, the manufacturer, or the seller of the machine, who was the vendor who provided that machine. These are 7 attributes or the information columns you can say. And we are expected to sort of perform exploratory data analytics on this to be able to identify uh, why it happened in past, right? Why machines got damaged. So let me show you a structure of data so that we can understand, what data are we dealing with, and what kind of problem are we going to solve. So let me first load data. With that, I'm going to be using few packages like import pandas, import numpy snp, right? So let me so I'm going to just copy this URL. If you want to have this data, I'm going to also share the link of this data in the chat. Right, this is the URL, and we can just directly pass the URL here. So I'm going to say, we can simply say URL and URL. Finally, we can say that here, we want to see the data, so I can say here. This is the data that we have, right? So what do we have as part of our data? Yeah, it's there already. The link has been shared essentially in the chat. You can directly pass the link in the pd.read CSV. If you get a file, you can also then convert or download that from the data frame as a CSV or Excel file. You can also save as by going to that link, opening that link in the browser, right click on the web page and save as a CSV file as well. Oh, okay. The file, the Jupyter notebook. Sure. At the end of session, I can share that, because right now I don't have any code in going further. I'm going to be writing the code in front of you. All right. So at the end of session, I can share this file. Okay. So here we go, everyone. Let's understand the data, right? So this is the data that we have. We have the data of around 1,000 machines. You can see that we have total 1,000 rows and 7 columns, right? So these are the data we have: 1,000 rows, 7 columns, right? And we have, as part of our data, we have data of 1,000 machines. For each machine, we have lifetime. What is lifetime? As we can see, that lifetime is lifetime of the machine in months, right? So how many months it's been? So this machine is 56 months older. This machine is 81 months older. This machine is 60 months older, 86 months older, 34 months older, 88 months older, 88 months older, 22 months older, like that. Then second is we have broken. Broken shows whether the machine was damaged or not when this data was recorded. So 0 means yes, no, this machine was not damaged, it was not broken. 1 means yes, this machine was damaged. 0 means no, this machine was not damaged. 1 means yes, this machine is damaged, not damaged, 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 damaged. This is what they are worried about, right? Because if a lot of machines are being damaged, that's an issue, or that's a performance issue in the company, right? This is one of the KPI, key performance indicator of about how well the factory is working, right? So the number of machines which are broken should not be quite higher, which is actually higher in this case. Then we have the pressure index, that is the value of pressure on which the machine was operating, the value of moisture which machine was generating, the value of temperature on which the machine was operating, right? The team which was handling the machine. So this machine was handled by team A. So every row is one machine, right? Every row is one machine. First machine was handled by team A, team C, team A, team C, team B, team B, team A. Like one team used to handle multiple machines like that. So which team was handling the machine? Who was the vendor or manufacturer of the machine? So provider 4, provider 1, provider 2, provider 1, right? So the question is that what are the advantages by this? So you see, one of the issue is, one of the problem that we are trying to solve. What is the problem? The problem is to understand why machines are damaged. The business identified that there are a lot of machines which are damaged, right? So the business identified, the broken column shows that this machine is damaged, this machine is damaged, this machine is damaged, this machine is damaged, like that. So there are multiple machines which are damaged. There are some of the machines which are not damaged. So the problem is to identify or to explore from this data why the machines are damaged, right? So we need to identify the reasons why machines are damaged. If the business know these reasons, yeah, I mean, from this data, whatever issues we can identify, it's up to us, and what techniques can we use. So we have to use our skills of data analytics to identify, we have to apply statistics, visualization to identify why machines are damaged. If we can do that, if the business knows what are the possible reasons machines are damaged, business can take better actions for the next cohort, or you can say next coming few years, so that they can reduce the damage percentage, right? Let's say if they identified the machine which are generally operated on higher temperature are damaged, so they will now put a threshold that we don't want the machines to be operated on higher than this temperature. If we identify that the machine which are operating on a certain higher pressure are being damaged, then they will accordingly take action and ask the factory factory employees not to operate the machine higher than this value of pressure. In case these are just some guesses, right? We don't know at the moment. We don't know at the moment what are the reasons why machines are damaged, which is what we want to explore from this particular project. We want to identify what are the possible reasons why machines are damaged, right? I hope this is making sense to all of you, everyone. Let me know. There's a question. So can you show a whole demo by any? Yeah, this is on this part, we're going to be seeing the whole demo actually. I mean, on this particular data set, we're going to see the end-to-end analytics of identifying why machines are damaged. This is what we're going to do in this workshop meeting, right? So we'll be using statistics, we'll be using data and visualization, we'll be using a lot of techniques to identify why machines are damaged. I hope that makes sense, right? So we're going to be learning, this workshop is going to give you, on this particular project, we're going to be working on to identify reasons why the machines are damaged. Those could generate or act as few suggestions to the factory owners in terms of what they should do in order to reduce the percentage of damage of machines. So are we all clear with the understanding of data? Each and every column. It's super important that you understand each and every column, and let me know if you're good with that, and understanding what problem are we trying to solve, right? So these are two important things. One, what problem are we trying to solve? Second, what is data? What each and every column represents, right? And yeah, the first one is what problem are we trying to solve? So please confirm me in the chat if you all are good with the understanding of what problem are we solving, one, and two, what exactly these particular data points represent. Right. So I'm considering that it is all clear to all of us, everyone. We all are good with understanding of what problem, one, and the second is the what exactly these data points represent. So what exactly is lifetime, what exactly is broken, pressure, moisture, temperature, team and provider, right? So let's start with that, right? So first we need to understand how to approach any such issue, right? So this is one of the analytics problem. You might get to deal with multiple such other analytics problems. So what kind of template should you follow, right? Or what are the methods to be followed in general when it comes to approaching any standard data analytics use case, right? So how do you go about that? So let me show you a blueprint, right? So let me show you a blueprint of any data analytics project, right? So how should you approach any data analytics project, right? So instead of, let's say you're working for a telecom company and say company says that, well, we want to identify why customers are not, why customers are opting for MNP, mobile number portability, why they are shifting from Airtel to Vodafone or Vodafone to Geo possibly. Or you might be working for a bank and the bank might want to get an answer to the question why possibly customers are not buying credit cards, right? So there might be different issues or challenges. So how to approach any such standard analytics issue, or you can say how to approach any such standard analytics project. What should be your standard step-by-step techniques that you'd want to use them, right? Which is what we're going to be looking at in this blueprint, and then we'll be following the same blueprint, right? So that's the idea. There's a question: is there any software or something? Can I know from where we can access it? What you want to access? This file currently, this Jupyter notebook. You can actually code in the you can write the same code what I'm writing in the Collab, right? So Google Collab is a free service to write the Python code. So you have to type the code in that case. But yeah, you'll be able to see the same thing, right? So you can go to collab.research.google.com. Right, so I'm using my local Jupyter notebook, but yeah, this is where you can actually start with, right? In case you want to code everyone, right? So I'm going to share the chat. So in case you are not used to with Python, so this is where you can start with, right? So I have not shared you this notebook because I'm going to be writing the whole code in front of you, right? But yeah, on Collab, you can write a new Python notebook. You can start with a new notebook and you can write the code as well in case you want. Right, so let's go further. So yeah, we're going to be looking at the idea of blueprint of what are we going to, how should you approach any standard data analytics project. So Join, yes, I think recording of this session is going to be shared. You should be able to access. You will have to connect to your point of contact at the company Technical Ventures, and I think that should help you out to get the link for video. So here we go, everyone, and let's look at the idea of the blueprint of any standard data analytics project, how it should be structured, right? And how it should, how should we approach it? So we're going to be splitting this into simple 5 steps, right? So 5 steps to take to work with any data analytics project, right? So that's what we're going to be looking at. So what are the 5 steps? The step number 1, the super important step is, right? The step number 1 is the step number 1 is the idea of we call it as domain exploration. So whenever you work with any data analytics project, the first step you should do is you should explore the business domain as much as you can, right? So you should go ahead and understand the business, right? Understand the business structure, how does it works, and understand the different business processes, how does it function and all, right? So this is the super important thing. Okay, and so that's one thing. Just a second. Yeah. So first step is domain exploration, where let's say if I'm working with banking organization, bank says that you want to perform data analytics on why customers are not buying credit cards or why they are not buying insurance. So first I need to understand the business of insurance. How does it work? All right. So and why? What are the general standard issues? How do the business resolve the issue? So the very first step is you should spend time on understanding the business process, right? So how does the process happens? For example, in case of this, in this case, you would want to understand why usually the machines get damaged, or what the business do when the machines get damaged. Do they sell it out, or do they scrap it, right? Or what are the common other challenges that they face? You know, if the machine is not damaged, some other small issues, how do they handle it, right? So you want to understand for what purpose they use the machine, what kind of production they do, how many hours they use daily. So these are common understanding that you want to collect before working with this project, right? So this is where you don't start with programming. You don't have to start with data. You have to just go to the business, the people who actually work on the floor, work in the industry, talk to them, understand the process, ask them questions, relevant questions, and pen down all the answers, right? The common understanding, because you have to start on the top of, as a data analyst, you have to first become equivalent to any employee in that company, and then you have to start on the top of their mindset, right? So wherever they finish, that should be a starting point. So you have to first reach to their finishing point, right? So understanding the business process, understanding the common challenges business usually face and how they handle or tackle it, right? Identifying few business beliefs, right? So business might say that usually machines, when we don't use it for 3 days, it doesn't work well, right? So every business may have some beliefs, right? Some belief which they consider as a universal truth, or maybe consider as a business pattern. Some beliefs. Every business process will have some beliefs. For example, okay, if the customer is coming from this area, he will not buy credit card. These are common beliefs in the banking business, right? Or if the customer is having age less than 25, he will or she will not buy a credit card. So that could be a common business belief. If the machine is bought in the month of February to March, the machine will get damaged. That could be a common business belief, right? So identify. Sometimes those beliefs have a pattern, a business pattern. Sometimes they are just not useful beliefs. So identify all business beliefs, possible reasons, because later you want to perform data analytics and verify these beliefs, right? So these are common challenges that you actually bring, questions, tasks that you actually bring from the floor of the business, where the business is actually functioning and they're actually using that product. This is the very first step as an analyst we should start with. The second step as an analyst is, the second step of any data analytics project is data collection and data exploration, right? So this is the second step you should deal with, which is so this is where now once you are done with the first step, you start collecting data, because once you do the first step, domain exploration, you know exactly what data do you need. You might want to ask to different stakeholders of the business to provide you a set of data, right? Different units of the business as well. In some cases, you may have to also collect data from outside the business, which could be some common sources, social media possibly, or possibly the general, let's say, weather data from any particular website, or maybe the World Bank data, the economic crisis data possibly, right? Or maybe the government policies in manufacturing that might also impact the purchase of machines, right? Or maybe the quality of machines as well, right? So these are different challenges or maybe extra data that you want to collect, and then you want to do an exploration on that data, which is where you would want to identify. So collect data from inside and outside business if needed. It's not always necessary that you need outside business data. In some cases, you have to identify that. It's your call to take, right? And then explore data and collect common popular issues with data. So with your experience of data analytics, you will gather that what are the common challenges with data, and you want to simply you'd want to simply collect those common challenges or common issues, and which you want to later very deeply verify them, or you can say by very deeply explore them out. Right, so that's the second step. The third step is data cleaning, right? So data cleaning, which is where what you do is, so now every data may have a lot of challenges. It might have some missing values, some duplicate entries, and you have to handle them. So what you do here is you have to handle duplicate entries, handle missing values, handle outliers, exceptional cases, or maybe some unnatural values, right? So these are the exceptional cases that you don't want to handle them, right? These are the steps that you need to take on cleaning. And the fourth step is super important step, where we actually perform analytics, right? And that's the super important step that we should take care of, and that is exploratory data analytics, right? So this is where you start actually doing data analytics. There are two ways to perform analytics: one using visualization, and two using statistics, right? So using, or you can say EDA, using data visualization. As part of that, we perform, let's say, univariate analytics, bivariate analytics, and multivariate analytics. And next step, sorry, so this is one of the methods, which is using visualization. The other method is also to perform EDA using statistics, right? So that's another method to perform EDA using statistics. As part of that, what we do is we perform, let's say, we use a lot of statistical methods, which could be correlation analysis, which could be hypothesis testing, a lot of them. And finally, creating report, right, of conclusions, suggestions, and red alerts, right? So from all the steps taken, we identified different conclusions, few red alerts possibly, and few suggestions. Red alerts are just immediate action that they should take or they should be worried about. Right? So yeah, this is the journey of any standard data analytics project, the 5-step journey, that you can think of this as a template that you don't want to perform on any data analytics project. And we'll be also using the same template for our project as well. These are the steps that we'll be following. These are the steps that we'll be implementing in this data analytics project, right? So I hope we are good with this. I'm super excited about doing this, right? And going through this with you. Let me know in case you have any question, if you want, right? Meanwhile, we have a question. By running these commands, we can see the certificate as well when we any type of software or any application is published as well as expired in computer. Is that right? Well, it depends. I mean, what kind of commands are we using, and insert mgr msc. Okay, that could be one of them, right? That could be one of them, Jisan, right? So it's I guess a Visual Basic command, right? And it should lead to that. Okay. So, but I think that are we all good? Could we go further? Right. So let's move further now. We're going to be going further, and this way we're going to be starting first with the very first step, which is the domain. Not the first step. We are not going to doing that. We're going to start with the second step, which is like data exploration. We already loaded the data, so here we go. Yeah, so if you don't have enough data, Hiba, in that case, a way to handle outlier is to consider the outlier itself as a missing value, and then substitute it with impute it with a mean, median, or mode. Right, so that is one of the way. In case you have large volume of data, so you don't have large volume, and you don't want to remove the outlier, you don't drop it, because that might lead to data. Right, so if you want to handle such situations, this is one of the way. You treat the outlier as a missing value, and then you take the action that you usually take on missing values. Okay, that's the idea. Right, so here we go. So here we go and start with it. Right, which is so we already loaded the data, right? As you already know that we already loaded the data. We have DF, which is the step, right? So this is a data set that we have. So we're going to starting with the step, which is step 2, called data exploration. We have already done collection here. So as part of exploration, we identify some common challenges of the data. So we look at df.head again, right? So these are the columns that we have. So I hope we are now good with the meaning of each and every column in general. What is lifetime, what is broken, what is pressure, what is moisture, what is temperature, what is team, what is provider, right? As we can see that we do not have any identifier of each machine, right? So we don't have something called machine ID, or we don't have any machine number, or maybe machine chassis number, or maybe machine purchase number, anything like that, or order ID possibly, right? Or machine the date of purchase of machine possibly, or date of deployment of machine. We don't have any such identifier of the machine, right? We just have only the quantitative and qualitative information, a little bit about that. So in head, you kind of see the structure, understand the structure while looking at df.head. Head simply shows you top 5 rows of the data frame, and it's simply you understand each and every column, see the structure of data. The one thing you do is df.info. Info gives you the overall information about data. That says that we have data around 1000 entries, which is starting from 0 to 999. Definitely data cleaning is a big challenge. We're going to be actually dealing with that, right? So we may have such some issues, to deal with. So yep, we have 0 to 999, right? So these are the 10,000 1000 entries that we have. So we have around 1000 values of lifetime. The data type is int64, broken, int64, float, integer, float. These are different data types. Well, for 2 attributes, we have the data types as object. For pressure and temperature, you can see that it is not 1000. So there are few missing values in temperature and pressure that you would want to further explore at the point of data cleaning, right? So you can say one of the analysis we identify over here is data has some missing values. Right, so we are not exactly counting or cleaning them at the moment. This is just the exploration, right? The rest of the columns are quantitative, like int, float, but these are qualitative. Object means they have string. These are qualitative. You would want to further explore them, right? So team and provider. As you can already see, these are just team and provider are string. So team and provider columns are in string format, right? So we have total 54 KB of memory, or you can say a space it's taking in the RAM currently, right? And yeah, that's the idea. So for team and provider, we want to further explore that. So we can say df.team.unique and df.provider.unique. Right. So we have in team we have three values like team A and team B and team C. These are three different teams which are operating all the 1000 machines. They have four providers: provider 4, provider 1, provider 2, provider 3, and like that. So these are provider 1, 2, 3, 4, four providers, which are these are the people who, or these are the vendors or manufacturer possibly who provide machines to the factory, right? So that sort of information we have, right? So in data exploration stage, you just explore the common things or common issues or maybe common structure or noteworthy points about the data, right? So we identified that these are the four manufacturers or vendors who are providing machines to the factory, right? This is what we do as the second step, with the point of data exploration. Next, similarly, we can check his df.describe. Please feel free to ask question at any point, right? So put questions. So describes gives a statistical summary of the data, right? So it gives simply the statistical summary of each attribute, which includes the lifetime. There are 1000 values. The average lifetime of all the machines is 55 months, right? So all the machines are on an average useful up to 55 months, and the standard deviation is 26. The mean is the minimum value. That means the minimum number of month any machine is having is 1. All right, and 34 is the you can say 25% of machines are less than 34 months having, they're having lifetime as less than 34 months. Half of the machines are less than 60 months and half of the machines are more than 60 months. That means half of the machines are purchased 5 years back, and you can say in purchased are more than 5 years old, and half of the machines are less than 5 years old. 75% of the machines are less than 80 months older. 25% of the machines are more than 80 months older. Maximum age of machine is 93. That means the maximum machine lifetime of machine is 93 months, right? Which is somewhere around, let's say, 7 to 8 years, somewhere in between. Broken is a categorical attribute, right? So only the mean makes sense here, 39. That shows that out of all 1000 machines, 397 machines are damaged, right? Which is like 39.70 machines, 39.70% of all the machines are damaged, right? Are broken, which could be a big concern for the enterprise. Pressure index. The average pressure on which machine was operating, average moisture, and average temperature on which machine was operating. 75% of the machines were operating for pressure less than 112. Yeah, we can find that how many machines are in the max lifetime, right? So how many machines are having ages 93? We'll see that exploration as part of Predictive Analytics. We'll explore that. So 112, 75% of the machines are operating for pressure less than 112, and maximum pressure on which machine operates is 173. Moisture, 75% of the machines operating for less than 113, but the highest or maximum moisture is 1156, which is quite huge difference. You see here, there's a huge difference between 75% versus max. There's a huge difference in that, right? That shows that there may be few outliers in the moisture. Temperature as is proper, 113 and 172, you can say it's almost proper. Okay, so that's one idea about it. Have we looked at this, right? So we can say, we can have a doubt here at the moment that looks like the moisture attribute may have an outlier, an exceptional case, right? A very high value, 1156. 1 or 2 or possibly 3 outliers, or maybe 10 outliers as well, right? Yeah, so we can see that we have few possibilities of the outliers in this case of moisture, and that's one of the analysis that we kind of do here, or sort of identify here. One of the challenge with the data that we identified here. Okay, So now let's move further about that, right? So data exploration is more of identifying some common issues or common challenges with data, which later you'll want to investigate into that to assess that why it happened possibly, right? So that's about exploration. That's about common exploration. Now we'll move to the third step, which is about data cleaning. We'll move about third step, which is about data cleaning. So first we'll check with we'll check for duplicate entries. Do we have any duplicate entries? For that we'll say df dot duplicated dot sum. So we do not have any duplicate rows in data. That means the whole row is duplicated. That means the lifetime, temperature, pressure, broken of the machine, everything is same. That we don't have any information. The team manufacturer is same, so that we don't have any such machine or the set of machines which have the you can say common values of the attributes, or they are having almost all the same values. So we don't have any duplicated rows or any duplicated entries here, right? So that way our data is good, right? We don't have to deal with duplicate entries here, right? So otherwise we would want to drop them. Next, check for missing values. As you already know, we may have few we identified earlier, right? So df dot is null dot sum, right? So we can look at the here that we have 4 values missing in pressure and 3 values missing in temperature, right? So we have 4 values missing in pressure and total 7 values missing we have, right? And so that's where we have you'd want to deal with them. One of the way to deal with missing values is you want to drop those rows wherever there's a missing value. That's one of the way to deal with it. But that may not be always the right approach, because when there's a missing value in one column, right? So as there are 7 columns, if one of the column has missing value, but rest 6 are real values. So for the sake of one missing value, you may not want to lose the 6 real values, right? So that's where instead of dropping the missing values, you may want to impute or substitute the missing value with a statistical aggregated value. That could be mean or median or mode of that particular column, right? So we go to the idea here. We would not want to drop those rows where we have missing values. Rather, maybe we would want to fill in the missing values by some statistical value, which could be mean or median or mode of the data. Okay. So let's do that here. Now to identify whether to substitute it with mean, median or mode, how do you decide that? So how do you decide whether what action to take? How do you decide that whether should I fill in the missing values by mean, median or mode, right? So there are a set of guidelines to do that, right? So guidelines to handle missing values, right? So the guideline is, if the data is categorical, you look at if it is nominal, the good representative of data is mode, so replace it by mode. If it is ordinal, median. In our case, temperature and pressure both are numeric, not categorical. If the data is numeric, right? So if data is numeric, right? It is not categorical, rather it is numeric. In that case, a suggestion is to check skewness, right? Check skewness, and or you can say in that case suggestion is check skewness, and if it is skewed distribution, then median with the left or right. If it is normal distribution, then mean, right? Or in normal distribution, mean is also closer to median as well, so you can also think of replacing it with median by default. So these are the guidelines. In order to check skewness, if the skewness is between minus 0.1 to plus 0.1, then you can say it is more of normal distribution, almost normal distribution. Else we call it skewed distribution, right? So that's the idea. So these are the guidelines that you would want to possibly use to check the, how do you do the cleaning of missing values, right? So in our case, we'll check the skewness, right? So let's say that we're going to do that here. Okay, so we'll say that df dot q. We are missing values in pressure and temperature. As we can see that for temperature, it is closer to 0. It is less than, it is between 0.1 to minus 0.1 to plus 0.1. Whereas for pressure, it is just above that. It is not very much above plus 0.1, it is slightly above that. You can still think pressure as well also as a normal distribution, but temperature is very much normal distribution. Pressure is close to normal distribution. If you want to strictly follow that rule, then in case of pressure, you don't want to impute the missing values by median. In case of temperature, you don't want to impute it by mean, right? Otherwise, in both the cases, we can use mean as well as in case of pressure. Also, it is not very much skewed. It's very much closer to normal distribution, whereas temperature is almost normal distribution. Skewness shows the pickedness of the data, how much data is peaked up, right? So that sort of information skewness represent. And you can say whether mean is a good representative of data, whether median is good representative of data, that can be interpreted from skewness, right? To help you better understand skewness, maybe I can give an example. That could be, sure, Omkar, I think you should be able to drop an email to the support team at or maybe the team with which you are in point of, who is your point of contact, and maybe they should be able to help you out with that. So I think my whiteboard, I hope all of you can see my whiteboard screen, everyone, right? So we're going to be understanding the meaning of skewness in general.
Sir, how to do it?
What? I didn't.
Asking the recordings to the support team.
Yeah. So it is being recorded. You can connect to the team. Let's say you would have received an email regarding this webinar.
Yes,
you can just reply to them and they'll share you the link of it.
Okay. Thank you.
So in talk about skewness, there's a question: do we need to have expertise in statistics before working on any data science project? Need not to have very core expertise at initial level. You should have idea of applied statistics, right? So when I say applied statistics, let's say you need to understand what is variance, what is standard deviation. You need not to remember the formula of variance and standard deviation. So when you say expertise is more on academic level, right? So you don't need the academic expertise. You need more of applied statistics understanding, right? So rather than remembering the formula of any particular statistical method, you need to understand when to use it and what sense does it make, right? So I'm in explaining you skewness, I'm not going to show you the formula of skewness. I'm just going to help you understand what exactly the information skewness interprets, and what do we interpret from that, and what do we conclude from skewness in general, right? There's a formula to calculate skewness which I can show at the end, but that's not a necessity, or maybe that's not a super important thing to understand or to remember. But yeah, understanding the essence of skewness, what exactly set of information does it represent, that is important. So let's go and talk about it. Now that answers your question. Here we go. So we're gonna be understanding skewness. Let's take an example here. So let's take an example here. So let's say we have information about the marks obtained by students in a math exam, right? So we have data of marks obtained by students in a math exam, and we have number of students, right? So for each students we have marks obtained, and we are drawing a graph between number of students versus marks obtained by students, right? Now let's say if the exam was super easy, exam was very easy, then can we say that majority of the students in the math exam will get high marks? I hope all of you agree to that. That if the exam was super easy, majority of the students are going to get high marks, right? And in that case, the distribution of marks is going to look like this. The distribution of marks is going to look like this. If I have to draw it a very smooth curve, it might look like this, right? Where, as you can see that at a higher at a higher marks, you can think of this as, let's say, this is showing like 100, this is like 90, this is like 20, this is like 30, right? So these are the marks. So you can say that at a higher marks, there are very high number of students, right? The number of students are higher. Okay, so that sort of interpretation you can see here, right? And so the exam was super easy, majority of the students got high marks, right? So everyone is happy about that. But then there were few exceptional cases like me who got lower marks even in easy exam, as you can see here, right? There are few exceptional cases like me who got even low marks, right? These are the people who got low marks even in easy exam. Sorry, yeah, even in very easy exam. So that's where right, that's where these are the people who are, you can say, these are the people who are more of exceptional cases, or you can say outliers, right? Now, because of presence of these people who got low marks, even the exam was super easy, right? Everybody got high marks, but these are 2-3 students who got low marks. Because of this, the distribution of data becomes skewed, right? So what do you mean by that? Let's understand it. So when you look at this statistic here, I mean this distribution here, the highest peak represents the highest peak here. This peak represent that this particular marks, right, which is like this marks, was obtained by maximum number of students, right? So because y-axis is representing number of students, that means this marks, which could be, let's say, 85 or 80, was scored by maximum number of students. So always the highest peak, the corresponding x-axis is mode of the data, right? Always in any distribution, highest peak is mode, which is the marks obtained by maximum number of students, right? The central value is always, in any data distribution, the central value is always the median, because if you arrange your data in ascending or descending order, the central value will not change, which would be, let's say, 50 or 55 marks somewhere around, right? And that's the median of the data, right? The central value is median. The central value on the x-axis is the median of data. Now, everybody got good marks, exam was super easy, but there are few outliers who got low marks. Because of these exceptional cases, the mean of the data shifts down. Because of these exceptional cases, the mean of the data shifts down, and that becomes a challenge in the data, right? So that becomes a specific challenge in the data, right? So because of these low scorers, the mean of data goes even down, and the mean somewhere comes to here. So this because of this, you can say that this slant is observed, right? This slant is observed. This slant is observed, right? This slant, or you can say this particular slant, right? So this slant is called as skewness, right? So this is geometrical meaning of skewness, and mathematical meaning is the mean shifts from median either below or above. That's called skewness. Here the mean is shifting below median. It is less than median if you look at the marks, right? So we call this data as left skewed, or this distribution is left skewed or negative skewed, right? So we call this distribution as left skewed distribution or negatively skewed distribution, right? So because of few outliers, the mean shifts down, right? So if I have to show you a practical example of this, it could be, let's say, right? So let's say that they have marks which is like 20. The marks scored by students are like 95 plus 98 plus 96 plus 99 plus 92 plus 93 plus 94 plus 91. These are the marks obtained by students, right? But then there are few low scorers like 22, 21, 23. Now, because of these low scorers, what will happen? If I look at some of the values, it's 1017. If I count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to add one more, right? Which is, let's say, 20, right? Okay. So this is the marks of 14 students, you can see, right? So if I look at mean, so you can say mean is going to be the sum of all values divided by the count, which is like 14, that is 74. The mean turns out to be 74. If you look at median of the same data, so for median, I have to arrange the data in ascending order or descending order. If I arrange that in ascending order, it becomes 20 is the lowest, 21, 22, 23, right? So this is where I'm arranging the data in ascending order to calculate median. And then it comes 92, 93, 94. Oh, I missed 91. 1, 3, 4, 5, 6, 7, 8, right? And so 94 is there, 95, 95, 10, 96, 98, 98, right? Which is like 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and there's 99, right? So if this is the data, if I look at the median of this data, there are 14 values. So the median is going to be 14 plus 1, which is like 14th value and the 15th value, the mean of them, right? So you can say that 14 by 2 is 7. So it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 7th value is this. So median is going to be the mean of these two, average of these two. So that's going to be, you can say, 93.5. That's the median of data. So in this case, can we say that mean has shifted below the median because of few exceptional cases, right? Because of these exceptional cases, majority of the students got high marks, but there are few students who got low marks, right? So these are the exceptional cases. Because of these exceptional cases, the mean has shifted down. It is only 74, whereas median is 93, right? So in out of mean and median, which is good representative data in this case? Majority of the data are closer to mean or majority of the data are closer to median? What do you think, everyone? Is it that majority of data is closer to mean or majority of the data is more closer to median? What is good representative data? So I hope all of you agree that in this case, median is a good representative data. Majority of the data points are closer to median, right? So whenever data is skewed, that means there are few outliers or maybe some few exceptional cases. Because of those, the mean shifts either left or right, and mean is no more a good representative. Mean becomes biased, right? So that's where median becomes a better representative data, right? So in this case, you can see that majority of the data points, which are like this, majority of these data points are more closer to median compared to mean, right? So majority of the data points, which is like this, majority of the data points are more closer to median compared to mean. Okay, so that's one of the situation. So we call it left skewed or negatively skewed. In this case, if you calculate the value of skewness, it will be negative value, or it will be it will be always a negative value. Similarly, in another situation, if let's say the exam was super easy, it was not difficult, rather it was super easy. Exam was very easy to deal with, right? Sorry, the earlier was easy, right? So this was easy, And let's say another situation, exam was difficult, right? So if exam was very difficult, majority of the students will get low marks. So the data distribution will look like this. Exam was super difficult, majority of the students got low marks, but then there are few exceptional cases, like many of you who got high marks even in difficult exam, right? And these exceptional cases make the mean shift higher. So the highest peak, right? So x-axis still represents marks, and this represents the number of students. Right. So highest peak is still the mode, right? So you can say that this is the mode. Central value is median, right? Central value is median. But when, because of these few example cases who got higher marks even in difficult exam, mean shifts higher, right? So mean is above median. So we call it right skewed or positively skewed, right? Right skewed or positively skewed. The slant is skewness, you can say. In this case, majority of the data points, is it more closer to median or mean? So in this case also, it is skewed, right? So is it more closer to median or mean? What is good representative data? So I hope all of you agree that in this case also it is median to which it is more closer to, and median is good representative data. So whether the data is positively skewed or negatively skewed, median is good representative data, right? Now third case, where it is not skewed, the exam was neither more difficult, it was nor more easier, it was normal exam. So if x-axis shows marks and y-axis shows number of students. If the exam was neither difficult nor easy, the data distribution would look like this, right? And in this distribution, the highest peak, the highest peak, as we already know that, it represents the mode. As the highest peak is occurring in central part of the distribution, that is also closer to median, and that will also become closer to mean as well, right? So in ideal normal distribution, they'll be equal to each other, but in general normal distribution, they will be closer to each other. In this case, we call this distribution as normal distribution. And here the skewness becomes almost closer to zero, right? So we call it normal distribution. In this case, we consider that mean is a little bit representative of data because mean, median, mode are three closer to each other. So we still give more importance to mean because calculation of mean incorporates all the values, whereas median is just a single value out of the large point of data, pool of data. So we give more preference to mean in this case, and you can say mean becomes a representative data when it is zero skewness or normal distribution, right? So I hope this makes sense about the idea of skewness. What exactly is skewness, and how does skewness answer the question? What is good representative data, mean, median, or mode? Or in general, how do we use skewness in practice? So are we good with that? Right. So if we have missing values, and if we want to fill the missing values by mean or median or mode, we should look at, if it is numeric attribute, you should look at skewness, and if it is closer to zero skewness, you should fill it by mean. If it is very negative or very positive, you should fill it by median. Right? So that's how skewness helps in general, and that's how that's the meaning of skewness in general. There's a formula to calculate skewness, which is like which is median minus mean upon standard deviation, right? So that's the standard formula to calculate skewness. But you don't have to remember that. You don't have to remember what the meaning of skewness, what you interpret from the value of skewness. If the value of skewness is negative, it's the first condition. If it's positive, it's the second condition. If it's closer to zero, it's the third condition. Right. So if it is to talk, if these are the three situations, let me ask you a question. situation 1, situation 2, and situation 3. If it is stock market data, let's say that these are the three distributions of return on three stocks, stock A, stock B, and stock C. This is representing return of stock A, this is representing distribution of return on stock B, and this is representing distribution of return of investment on stock C. So which of the stock is more profitable? Which stock you want to invest into? A, B, or C? Which is the most profitable stock and which is the most risky stock? Right? So if these are the three distributions of return of investment done on the stock A, stock B, and stock C, so which is the most profitable stock according to you? Right. So I hope all of you agree that stock A is the most profitable one because majority of the return is higher, is above mean. You can see it is above median. Majority of the stock, majority of the investors got the return higher than mean, right? Whereas in stock B, majority of the investors got return lower than mean. In stock C, 50% of them got higher than mean and 50% of them got lower than mean, like that. So skewness is negative. If negatively skewed data that you have, that shows a good stock, right? That shows, so skewness can also be used to assess the quality of stock based on the value of skewness on the return gained on the stock, right? So I hope the idea of skewness is clear, right? Let me know if you go with that. Any questions? I think say someone. Are we all good, everyone? Any question you have, let me know. Okay, so let's move further, and we're gonna now shifting to the back. Yep. So yep. So we can see that skewness of skewness of temperature is very much closer to zero. It is between like -0.1 to +0.1. So we call it normal distribution. Whereas pressure, which is like more than +0.1, so it is kind of positively skewed. So let's fill in the missing values over here. So we can say that df dot temperature dot fill na df dot temperature dot mean. That means we're going to fill the missing values by mean, and we're going to say in place equals true to completely impute it, right, within the same data frame. And pressure. So pressure dot fill na df dot pressure dot let's say we're going to do it that by median and in place equals true, right? And now if you look at df dot is null dot sum, now if you check the missing value, so well we have few errors. So data frame has temperature index, so now you can see that we have filled the missing values and we don't have any missing value available. So we have filled the missing values in temperature by mean and pressure by median, and we have no missing values anymore. So we could tell here, if you want any question you have, let me know. And third, we're going to look at the idea of outliers. Right. So how do we handle outliers? There are multiple ways to identify outliers, right? But yeah, so how do we handle them up? We're going to be looking at that as well. Let me know if I go with this part so far. Any question you have with this? Are we all good, everyone? Good to move further to look at the idea of outlier. Are we all good to here? So in place central is to make the changes in the same data frame. So let's say that if you are filling the missing values, one of the situation could be you may not want to make the changes in the same data frame df. Rather, you want to keep it as it is, and you'd want to simply create a new data frame in which there should not be missing value. So in place true if you want to make changes in the same data frame, in place false if you don't want to make changes in the same DF. You want to create a new DF which could be DF2 which doesn't have missing value. Are we good with that? Right. So well, let's move further, right? Let's move further. So this is now we're going to talk about the idea of how do we handle outliers. So how do you identify outliers? Well, there are multiple statistical methods. One of the simplest methods I'm going to show you is like with Skewness. Well, that's one of the practice, right? So the method is like if Skewness is greater than +1 or if Skewness is less than -1, and that means yes outlier, right? So if you look at df.skewness, so outliers are exceptional cases, Aman. The meaning of outlier is an exceptional case. So let's say that all the machines are operating on temperature of 80 to 100 degrees Celsius, but there is one machine which is operating on temperature of maybe 500 degrees Celsius. So that's an outlier. Outliers are natural cases, but they are exceptional. Let's say that in a class there are students having age between 10 years to 13 years, but there is one student who is having age as 55 years. Now that is naturally possible. There could be a student of 55 years age, right? But they are outliers. They are exceptional cases, right? So outliers are natural, potentially possible values, but they are exceptional cases. In some cases, the outliers might occur because of the instrumentation error, because they are not they are not really outliers, but there might be some instrumentation error. They are unnatural values. For example, let's say if the value of age is 500 years, naturally it is not possible, right? These are also unnatural situations of having outliers. In some cases, it is natural, right? Which is technically possible, but then business context, based on business context, it is very different case, right? So that's an idea. So we have to deal with them. We have to handle them. Either you want to drop that particular row, or else you want to possibly impute that outlier with mean, median, mode, or stuff like that. So I hope that answers your question, Aman, about the idea of what are outliers, right? They are exceptional cases, but present in the data, right? Okay, so that's an idea. So as we can, how to identify that if there are some exceptional cases, very exceptional cases, so look at Skewness. If Skewness is greater than +1 or less than -1, that means there is an outlier. If it is greater than +1, that means there is a very high value outlier. Let's say that, most of the customers in a bank are having age between 20 to 60 years, but there is one customer having age 92 years, right? So that's an outlier. That's a high level, on the positive side, you have an outlier. And on the negative side, there could be most of the customers having age between 40 to 60, but there's one customer having age as 21 years, right? That's a negative side outlier, or lower side outlier. So negative Skewness less than -1, that means lower side outlier, more than +1, that means higher side outlier. So we can see that moisture has an outlier, right? As you can see that moisture has an outlier present in that. And, that's where we don't want to deal with that, right? So we have to deal with moisture having outlier. If you look at total number of values here, right? So one of the way to explore outlier is like, if you look at total number of values here, Skewness, sorry, df shape. So we have total 1,000 rows and 7 columns. We have total 1,000 rows and 7 columns here. And so if you want to explore the outlier of moisture, one of the way to see that is you can draw a scatter plot of that. So I can simply do df.moisture plot type equals kind equals scatter. So maybe we can simply draw a scatter plot saying PLD dot scatter, PLD dot scatter. On x-axis, we can say df dot index. On y-axis, moisture.
You have used df. Yes.
Yeah, thank you. So yeah, here we go, and this is our data, right? So if you look at this scatter plot of the data, there is also another very popular plot which is like box plot. That also gives you a very clear understanding of the outlier. But yeah, if you look at this, so you see we have data of the all the machines, right? So if I try to increase the size of this plot to make it interpretable more. And I'm going to make it, let's say, maybe 18 rows and 5 columns somewhere. So 18, no, my bad. 18 is the width and 5 is the height. Instead of 5, I'm going to make it, let's say, 10 as the height. So you see here, these are multiple dots. Every dot is one machine. And so every dot is one machine. And there are 1,000 dots on this graph. As you can see that most of the values are having moisture. So we are looking at the data of moisture. Moisture less than 200. You can see that most of the machines are having moisture value less than 200. But there's one dot which is actually crossing 1,000, and that's an exceptional case, right? That's an exceptional case. As you can see that here, I guess there's one such dot. Yeah, there's one such dot which is exceeding the value of 1,000. Looks like it's lower than 1,200. But technically, when we looked at the skewness statistical distribution, it was like 1,500 somewhere. That's a little challenging thing, right? But yeah, so you can see that there's one value which is exceptional, right? So this value is exceptional case, and that's an outlier. You can see it is very different from the majority of the data points. And in that case, maybe we would want to drop that. So in such situation, you can see that you can directly take an action. Well, let's drop all the values of moisture which are having value higher than 1,000 or maybe 500 or maybe 400. You can take a threshold, and higher than that threshold, you can think about dropping them. That's one way. Another way is use box plot method like 1.5 times IQR. Higher than that, you want to drop it. Another method is you can use Z-score as well to drop the outlier. There are such multiple methods to or approach to drop outliers. One of the methods we can look at is simply all the values more than 1,000, you want to drop it, and that's how we can drop this particular outlier, that this particular machine's data. Right. So to drop that, so let's drop the row of the row which contains the outlier. So we can say that df equals df where df dot moisture is less than 1,000. So that's what you said here. Now if you look at df dot shape after dropping that, let's see how many we have dropped. So well, from 1,000 we now got it reduced to 999. That means we have just dropped one row. And now if you look at df dot skewness, we can see that from 15 we have reduced it to 1.5, which is quite good. Still, it may have few outliers. As you can see that the values are a little higher at the moment. It's more than +1. Still, it may have few outliers, but still, this is something workable. It's not very higher than +1. Earlier it was 15, as you can see that 15.98, right, which is like very higher than +1. Right, so that's how we have dropped the outlier, and now the data would look quite simple, and you can see easy to integrate as well. So this is where we have handled the data part, and now we can say that we have almost a clean data to proceed further, right? So I hope we're good with this part, everyone, right? We're going to proceed further. So this is where we're done with step number 3, and now we're going to move to step number 4, which is where we're going to be working with exploratory data analytics, right? And this is where we're going to be using data visualization to handle the situation, right? I mean, to perform the analytics, right? So this is the main part which we wanted to actually come up with. Okay, so are we all good, everyone? Are we all good? Any question that we have to hear? So now we're going to be shifting to the most interesting
segment of this particular workshop, right? The most important segment, I would say, which is where we're going to be exploring about what's happening in the data and what exactly data says and why this happened, right? So why machines got damaged. That's the part which is going to come now. Yeah. So there are three main components of data cleaning. There are even a few more. So which include you have to handle duplicate entries, handle the missing value, handle the outliers. These are three main components of it. Right. They could be even more. You may want to drop the unnecessary or not important values, right? Or you may want to drop the columns which are all having same values, right? There is no other category. You may want to deal with unnatural values as well. This could be very other, but these are the three popular issues or quality challenges, the cleaning challenges that you get with data. Right? So we checked for duplicates. We didn't have any duplicates. We had missing values. We cleaned them. We had an outlier in one of the entry column. We cleaned that as well. Right. So you're following this template, everyone. Make sure that we remember that we are following this template, and that's where we have now reached to exploitative data analytics. Right. That's the most important part. This question, there's still skewness of measure is, yeah, it is more than +1. So for the outlier sign, it should be less than -1 or +1, right? So you can see that we have written the rule here. If it is more than +1 or less than -1, then it is a challenge. That is its yes outlier. And we can see that it is not, it is still higher than +1. It is higher than +1. So it is not 0.1. We look at +1, right, for outlier part. So it is still higher than +1. So you can say still there are outliers in this, right? But that's closer to 1. So we can say at this moment we can negotiate with it and we can proceed further. It's again our call. We can still dive a little bit deeper, draw a few more values to decrease the, draw a few more rows to decrease the skewness and make it workable. Right, but in this case, you see the volume of data is not very large, which is like only 1,000 entries that you have. So you may not want to lose more data at the moment. Right, so you have the answer to the question. And the good range, which is to have skewness between +1 to -1. Right, for not calling it outlier. Okay. All right, so that's a that's an idea so far. I hope we're good, right? I think we have reached to time as well for the day, right? And so we will not be able to complete this fourth step today, right? So we're going to be kind of keeping this for tomorrow's session in that case, right? So we have the session tomorrow as well, as we already know about that, right? So at the moment, then we'll take a, we will declare a call off for the day, and we'll resume this further tomorrow. And we'll work on the top of this tomorrow, right? So I'll try to share the Jupyter notebook, right? So we'll check with that, right? So you can just drop a link in email to the same email, and I'll ask the team to share the notebook. So thank you all for joining the session in that case. And today now we'll call off the session. We'll meet back tomorrow and continue with this part. Yeah, the fourth step is going to take a lot of time. We're going to be learning few more statistical methods, which include, the fourth step and fifth step as well. Yeah, but fourth step is going to take a lot of time. We're going to be learning a few more statistical methods as part of fourth step, which would be a little bit of idea about correlation analysis. We're going to be learning about the probability distribution of data, right? So this is going to be a quite interesting part, which is going to be covering up. We are not covering machine learning a lot in this case because that's again a very broad topic and requires a little bit more time to cover that more qualitatively. So there's more of we are going to be limiting to EDA so that whatever part we're covering, you can cover that in more detail. For machine learning, we organize similar other workshops as well, right? So we may have few more other workshops coming up in which we cover example specifically on machine learning. You can also explore our YouTube channel of Tech and Quenches. You will find similar other workshops taken in past, which cover similar examples on computer vision, NLP, and all. So you can also look at similar such videos of past webinars which have already happened in past, and you can go through them. It's Tech Trunk. I can check with the. I can actually possibly. Right, everyone. So I'm going to share the link to the YouTube channel. If you want, you can sort of. So this is the YouTube channel, and let me share the link to this. Okay, so yeah, this is the one you can check. The link I'm sharing in the chat. So we have had a lot of webinars and a lot of videos of such sessions are available on this channel. You can explore through them, right? So they are from a lot of videos. Okay, right. So thank you for joining the session today. See you all tomorrow, right? So make sure that you remember tomorrow we have a session, right? Continuity of this. So with this part today, we'll end up here and meet back tomorrow. Good night. Sure. Good night, everyone.